5 implausible technologies from fiction that are on their way. Number 5. Deleting or replacing memories. For some time, neurologists have known that the brain is not the biological hard drive that we may perceive it to be, with our experiences etched indelibly as memories. Rather, memories are not so much created as recreated, over and over, through a process known as memory reconsolidation. When an event is recalled, it is essentially recalibrated and refiled in the brain, often colored by the mood and mindset at the time of recall. This is how memories become unreliable. It is also how traumatic memories become less so over time as the initial emotional reaction to the event is adjusted according to the emotional state at the time of recall. This is, of course, particularly effective in guided therapy. More recently, a link has been made between a certain protein and the retention of memories. Certain drugs have had success with blocking unwanted traumatic memories in patients by inhibiting pKamycin production, which has the effect of severely limiting long-term recollection. Meanwhile, researchers have also discovered how to hack the brain's reconsolidation process to change the information being processed, essentially using the power of suggestion. One psychologist used this technique to convince subjects they committed a fictional crime, which they were later able to provide a detailed description of despite the fact that it never happened. It has been suggested that a combination of these two techniques, blocking pKamycin production while forcing recall of a memory, invoking the reconsolidation process, could basically result in that memory being deleted forever. Number 4. Lightsabers. Scientists accidentally created a photonic molecule heretofore thought impossible because photons have no mass. By creating a unique medium in which photons interact strongly with each other, they were able to get the photons to bond, forming a new form of matter made out of light. Of course, the aforementioned unique medium consists of a cloud of metal atoms cooled to just above absolute zero, but the result, according to Harvard University physics professor Mikhail Lukin, is not an apt analogy to compare this to lightsabers. When these photons interact with each other, they are pushing against and deflect each other. The physics of what's happening in these molecules is similar to what we see in the movies. You may have suspected that the lightsaber was not the first practical application to come to mind. This type of matter could be particularly useful in the development of quantum computers. It could also one day be used to make crystals of light, as well as the long-awaited holiday gift that is sure to result in a rash of accidental Christmas morning self-dismemberings. Number 3. Lab-grown humans made with artificial sperm and eggs. For some reason which we cannot fathom, scientists have long sought a viable technique for producing artificial human eggs and sperm. In 2014, Cambridge researchers were able to produce early, precursor germ cells which could develop into mature cells using human stem cells, a process only previously accomplished with rodents. As impressive as this is, Chinese scientists recently took it one large, scary step further. In June 2016, Nanjing Medical University published its study indicating that a new experiment with rodent stem cells produced sperm that were much further along in the maturation process. These sperm were missing tails and therefore had to be injected into a mouse egg, which became fertilized and developed into healthy embryos, which in turn became healthy, live mice, with no fathers. Given that developments on the human side of this endeavor seem to lag a year or two behind the rodent side, we can likely expect to see this breakthrough with human sperm in the very near future. Assuming that similar breakthroughs with eggs are not far behind, it could well be within our lifetimes that bioengineered organisms up to and including human beings become a reality. Number 2. Creating black holes. In a recent experiment that will likely secure Stephen Hawking a Nobel Prize for predicting it 4 decades ago, physicist Jeff Steinhauer used sound waves to create a simulated lab-sized black hole that could prove much of what has been hypothesized about them. This sound hole was created by supercooling and then rapidly heating helium to create a barrier that should be impenetrable by sound waves. This, however, was not what Steinhauer observed. Rather, as Hawking's radiation theory predicted that black holes will generate photons, Steinhauer detected phonons, little bundles of energy that create sound escaping the event horizon of his artificial black hole. Though the results have yet to be independently verified, the discovery is potentially groundbreaking and Nobel-inducing. Of course, scientists at good old CERN are busy attempting to make real black holes, albeit very tiny ones. According to the relatively new hypothesis of gravity's rainbow, the idea that gravity affects different wavelengths of matter in the same way that a prism affects light, scientists have calculated the energy levels at which they would expect micro-black holes to be detectable. If they are successful, this would in one fell swoop not only prove gravity's rainbow but also the existence of parallel universes. Number 1. Invisibility. Rochester University scientists have famously been working on this one for years, first using a series of lenses to bend light around an object. They recently upgraded to a digital version of the same technique, and they are absolutely able to make pretty much any object vanish, but only as an image, viewed on a display in front of the object. Their technique takes a lot of scanning and preparation, a stationary object, and that darn display, which is admittedly not as cool as an actual invisibility cloak. But consider, what if the cloak was made out of displays? While flexible, bendable displays have been prototyped by many tech companies, LG appears to be taking the concept absurdly seriously. They recently debuted an 45cm, super-thin display that one could literally roll up and swat a fly with, and it's not too difficult to imagine even larger, thinner displays, wearable ones even in the very near future. Paired with the inevitable, undoubtedly more powerful next generation of the Rochester team's light-bending magic, this makes an actual invisible garment seem like something that we might be able to pre-order for the next holiday season.